first video on my own channel, that is AI Talks with Tanya. So, before going into any topic, I would like to give a brief introduction about me. So, hi everyone, my name is Tanya Laha and I am an AIML consultant currently working in an MNC of India. And uh, my relevant experience in AIML is for around 3 years. Prior to that, I was in a different domain, but since I started exploring the world of AIML, I have learned a lot. I have experimented with different things, and during my masters, um, I have gone through a detailed discussion on statistics, which is the base of data science. I mean, since when data science was not there, it was only about statistics. People used to find uh, meaningful insights from data using different statistical techniques, and they relied on different statistical methods, and that's how data science was born. So that's why uh, before going into the advanced topic of AIML, I would discuss a few small but important topics of statistics which I felt it should be uh, learned by every data science or AIML aspirants. So yeah, so like uh, that, my today's topic will be hypothesis testing. So what is hypothesis? If we say in a layman term, hypothesis means any assumption. So in statistics, hypothesis testing is basically done to build any uh, I mean real facts, to build to check the reality of any assumption. So for example, I am saying that today it is going to be rain. I have just given a simple statement that by just looking at the weather, I can say that today there will be rain during afternoon. But will it be a fact, or it's just my assumption? So how will I prove it? So I have to back my statement with some proper evidence, right? So that is called hypothesis testing. With the hypothesis, the assumption which I have made, I should back it with some evidence. And uh, the process of converting an assumption into a reality or some decisions is called hypothesis testing in statistics. So now you all will ask, why hypothesis testing? Yes, as I said that in statistics we deal with two kind of I mean data. One is sample and one is population. What is sample, what is population, I'll not explain it in depth right now. I'll explain it in some other video, but I'll give you a brief overview. So sample means uh, uh, for example, you have a bucket of apples and you want to check whether those apples are sweet or not. So what will you do? You will pick 3 4 apples from there, from the bucket, and you will just test it that whether apples are good or not. So the basket of the apple is the population, and the 3 4 pieces of apple which you have taken out from there is called sample. So we take out samples from a big population just to uh, make some statistical decision on it, to test whether any kind of experiment, I mean basically to do any kind of experiment for for any population. We used to take help of samples, because if population is a larger, population is generally used to be a larger group than samples. So it's not possible for us to perform each and every experiment on a entire population. So rather than it, we prefer to take some samples of the population and perform all our experiment and then make the final conclusion on it. So that is why in statistics sample testing is very much common, and people used to do it very often actually. So uh, that is now my our main question was why hypothesis testing, because in statistics, as I said, we use samples, not the entire population. So sometimes whatever assumption we make, whatever hypothesis we make before the experiment, that can be very vague. I mean, uh, if we don't uh, give any proper evidence, or we don't perform any proper tests to validate those assumptions, those can be uh, unreal. So that is why hypothesis testing is one of the important stages of test. I mean, one of the important step of any statistical experiment. It helps us to prove any assumption with proper evidence, and just answer the question, is it really real or we are just making a wild guess. And I have also given a diagram of population and sample. You can easily understand what I was trying to say. Now, the hypothesis is defined into two types. One is null hypothesis and another is alternate hypothesis. What is null hypothesis? The basic or the original assumption which we make before any experiment, before performing an experiment, that is called null hypothesis. Suppose um, just beginning of this discussion, I said that today there will be rain. This is a statement. So here what will be my null hypothesis? So the null hypothesis is, yeah, there will be rain today in afternoon. And what will be my alternate hypothesis? Alternate hypothesis will be just the opposite of my null hypothesis statement. That is, in this case, there will not be any rain in the afternoon. So this is called the hypothesis definition, and before performing any testing, any hypothesis testing, we should clearly define what is null hypothesis and what is alternate hypothesis based on our use case. Now, next is different type of hypothesis testing. So there are mainly two types of hypothesis testing. One is one-tailed and another is two-tailed. Now one-tailed is divided into two types, left-tailed or right-tailed, and two-tailed is only the two-tailed hypothesis testing. So what is one tail and what is left tail and right tail, and what is two tail? So if you see in the diagram clearly, so this graphs and all I will explain you in a next video actually, because that will be another discussion if I start talking about it right now. So it's just for understanding, I'll just give a brief overview that if you look at this, what graphs I can call, these are like Gaussian curves in mathematical and statistical terms it's called, but in layman term it can call it a bell-shaped curve. Okay, it looks like a bell, right? A bell which you fit in our temples and something. So that is the shape of this curve actually. So in this bell-shaped curve, if you see, there are two portions where we can reject our null hypothesis. These are those edge portions. So if it is a one-tailed hypothesis testing now, then you will see the only one edge or one tail of this curve will get selected for rejection of the hypothesis, and the rest of the curve will uh, uh, will not reject the null hypothesis. It will fail to reject the null hypothesis. So if in the left tail curve, what is it? The left edge of this curve will get the will get the rejection of null hypothesis part, and the entire curve will look like do not reject. Similarly, for right tail, the right edge of the curve will fall under the rejection area, and rest of the area will fall under the non-rejection area. But when it is two-tailed curve, now then the uh, both the tail of this bell-shaped curve will get the rejection of the null hypothesis. So if you see here, both the left and right side tail are falling under the rejection area, and the intermediate area will fall under the non-rejection area of null hypothesis. So basically, if we write this one tail and two tail into equation, we will write like this. If it is a left tail hypothesis testing, then mu, which is nothing but the mean of our sample, it will look like greater than of the value. So basically this is an example of any hypothesis. You need not to look into that. Just see the symbols here. It is greater than equal to or just less than equal to, means it is falling under only one side of this curve, not the other side of the curve. Here also it is less than equal to, it is falling here, not here. Okay, but if it is a two tail, then it will just look like equal to, means the mean area, and not equal to, means it can fall both in either in left tail or right tail. Now, what are the steps of this hypothesis testing? So first, as I mentioned, you have to formulate the null and alternate hypothesis. That is the most important and preliminary step of a hypothesis testing. My next step is choosing significance level. So significance level I will explain you in later slides. So once these two are done, then I will determine whether my null hypothesis is one tail and two tail, which I just explained actually. So once these three are done, then I will collect the data and calculate the test statistic. So test statistics are nothing but there will be different kind of tests like T test, Z test, F test. All these tests we perform just to validate the hypothesis which we made regarding our use case. So those tests I will also explain in some other video actually. Those are having different concepts, but those tests are important to perform any hypothesis testing. So those are called test statistics. Now once the data is collected and the test statistic is calculated, we will compare the value of the test statistics with the critical value or the p value, and the final step, based on the p value, I'll make a decision that whether to reject the null hypothesis or to accept the null hypothesis, which we also call as we fail to reject the null hypothesis. Now, just now I have mentioned that significance level and p value. So what is significance level? Significance level basically a value which helps us to gain confidence that whether we should reject a null hypothesis or not. So generally we consider the significance level value as 5%. So suppose there is an experiment going on a new drug. Uh, so we have claimed that the new drug which we have manufactured, that is going to cure 99% of the disease, okay, or that is going to kill 99% of the germs which is causing the disease. And this is our null hypothesis we are claiming. And what will be the alternate hypothesis? That this drug will not cure the 99% of the germ. So now in this case, I'm whatever hypothesis testing I'm performing based on my null and alternate hypothesis. So after performing and calculating the test statistic, whatever value I have get, if that particular value, if the I mean after performing t statistics, I will calculate the p value definitely. So if that p value is less than 5%, which is less than 0.05, then what will I say? I will say I am rejecting my null hypothesis, which means my null hypothesis is not true. But if it is greater than 5%, then I will fail to reject the null hypothesis. I have to accept it. So this is the importance of significance label and the p-value in hypothesis testing. Mostly we consider 5% as a significance level, but in some cases like in medical domain we considered it 1, because there we have to be rigid with our experimentation. We cannot randomly claim something based on the test statistic output. So that is why we kept the significance level value very low, that is 1%. And for some easier experimentation where we need not to be much rigid, there we keep this value as 10%. As I mentioned, if the value of alpha is low, which means my experiment demands stronger evidence before rejecting any null hypothesis. I mean, if I am claiming the new drug is not going to cure the 99% of the disease, then it has to be backed with proper evidences. I have already explained p-value, but still I am saying that it is the probability of getting data as extreme as observed if x0 is true. So if I say that whenever there will be any test statistic calculated like t test or z test or f test, we will always calculate in the form of probability, which we also called as p-value. So based on the p-value, we decide whether we should reject a null hypothesis or we should accept it, because the value of the p-value will always be compared with the significance level, what we decide before starting the experimentation. So small p-value, which means, as I said, if the p-value is less than the significance level value, then I have to reject the null hypothesis. But if it is greater than the significance level value, then I will fail to reject the null hypothesis. Here I have given the same example of the drug, like this is just example how hypothesis test is generally performed. So suppose here my experimentation is with the new drug, whether it is more effective than the old one. Then here my null hypothesis is that it will not be more effective than the old one. It is equal to the old one, and my alternate hypothesis is that yes, the new one will be more effective than the old one. So here you might say that in my previous example I have given null hypothesis and alternate hypothesis in a different way. Here I have written a different way. So these are actually nothing, but it changes as per your use case. Whatever you decide as null hypothesis, you just need to prove it, that whether you are accepting it or rejecting it. That's it. So here null hypothesis and alternate hypothesis I have first segregated. Now what will I do? Once the null hypothesis and alternate hypothesis is decided, then I will definitely compare. I mean, I will definitely first check whether it's one tail or two tail. So here basically what I'm checking, the new drug is more effective than the old one. So my alternate hypothesis is it will be greater than the old one. So it is one tailed, because I'm not saying that it is not equal to. I'm saying it is greater than, means it is falling within a specific tail of that bell-shaped curve which I have shown you in the previous slide. So that's why it will be a one-tailed experimentation, not a two-tailed. If here I would have written like new not equal to old, then that was going to be a two-tailed experimentation, but here it is an one-tailed experimentation. So now everything is decided and determined. Now my task is to calculate the p-value using different text statistics. So here if I have calculated, my p-value is 0.02 and I have decided my significance level as 0.05, which means my p-value is lesser than my significance level. So that is why I am rejecting my null hypothesis, which in turn means that here my alternative hypothesis will stay strong. That is, the new drug will definitely be more effective than the old one. Now there are different type of errors in hypothesis testing. The first error is type 1 error and the second is type 2 error. What is type 1 error? When we reject any true null hypothesis, which means that if suppose your null hypothesis is true but you are rejecting it, so that type of error is called type 1 error. It is also called false positive. So this false positive, false negative term will you will also get to see in ML. In classification algorithm we use this kind of error matrix a lot, but here in this context, type 1 error is basically the false positive when we reject the true null hypothesis, and type 2 error is just the opposite one, when we do not reject the false null hypothesis, which means my null hypothesis is not at all stand strong, but I am failing to reject it. So that kind of scenarios can cause type 2 error. It is also called false negative. So that's all about hypothesis testing. I won't say that it is a big discussion, but I was just trying to give you the gist of this thing so that you can answer any kind of question from this topic. But still, if you have any kind of queries, do comment down. And if I have the question, I'll definitely get back to you with the answer. But if I don't have the answer, then I may need some time to go through all the relevant resources and find the appropriate answer for you. But till then, that's all from my side for this video. See you all in the next video with some other topic, and till then, bye bye.